let's talk about chain rule. If we have to calculate the derivative with respect to x of x to the 10 versus the derivative with respect to x of cosine to the 10 of x. So basically, if we look at the shape of these two functions, they look pretty similar. It's x to the 10, which is just the simple x, versus a function of x raised to the 10. So I can actually write this one I can write it in this format, d dx of some function of x raised to the 10. Right, so how are we going to do that? Well, I made a table where we have the basic formulas that we went over so far, and I'm going to construct the chain rule for when is not just the basic function. So the first formula is x to the n prime, known as the power rule, equals n x to n minus 1. So the question would be, in the chain rule, if I don't have just x to the n, but a function of x to the n, and I have to differentiate it, what's going to happen? Well, we are going to use exactly the same formula, so n is coming in front. Then we have u of x to a power less, but we always have to multiply by the derivative of this u of x, which we called it inner function. So for example, if I give you this problem, x squared plus 3x plus 2 to the 10, and we want to differentiate it with respect to x, we see that I don't have just x to the 10, but I have a function of x to the 10. So I have a u of x. This would be my u of x, the inner function. So what does the rule say? It says bring the 10 in front, copy your function u, right? You see how here it says u, to a power less, but do not forget to write the derivative of x squared plus 3x plus 2 prime, which we can compute that. So we have 10 times, and I'm going to do this derivative in front. So it's 2x plus 3, and then x squared plus 3x plus 2 to the 9. And we can multiply this together, and we have 20x plus 30 times x squared plus 3x plus 2 to the 9, or we can leave it in this format. Either way. Now, let's take a look at the second problem. So I'm going to erase this one and try to write the chain rule for my second formula. So if we, instead of e to the x, we actually have e to a function of x, and we have to differentiate it. How do we do that? Well, exactly the same way we do with the basic one. We just copy e to u of x times u prime of x. So if, for example, you have e to sine of x prime, we notice that this time it's different. I don't have just x as the exponent, I have a function of x. So this would be my u of x. Once you identify your u of x, you should be good to go. So we get e to sine of x, and then let's not forget to write our sine of x prime. So we get cosine of x, e to sine of x, and that's it. This is our answer. Let's do another one. I'm erasing them because I still want I want to write each formula on the same line. Sine of x prime equals cosine of x. So now, if instead of x we have sine of a function of x prime, then what's going to happen? I'm going to get cosine of u of x, but let's not forget to multiply our answer with u prime of x. So for example, if we have sine of e to the x prime, then I don't have just sine of x, I have a function. So this e to the x, it's our u of x. So it's going to be cosine of e to the x times e to the x prime. Let's not forget, this is the part that people usually tend to forget. Once you identify your u, that should show up all the time. So then the u prime. So we get e to the x, I'm going to move this one in front, cosine of e to the x. And so the next problems are very similar. So 4 prime would be cosine of u of x prime is negative sine of u of x times u prime of x. 5 tangent of u of x, right? So not just x but a sum function, is secant squared of u of x times u prime of x. So all the time you want to identify what's your u of x, and don't forget to actually multiply by u prime of x. 6 prime would be cotangent of u of x prime is negative cosecant squared of u of x times u prime of x. And then you can pause and try to continue or to fill in your formula. And I actually fill in all the formulas, and let's not forget u prime of x always shows up. So let's do an example. So let's say we have find the derivative with respect to x of cosine of sine of x. So if we take a look at all the formulas that we have, the outer one it's cosine and the inner one it's sine of x. So basically this would be the u of x. So we should think, what is cosine of u of x prime? So cosine of u of x prime is the 4 prime formula. I just use them prime. So it's going to be negative sine of u of x times u of x prime. So in our situation, it's going to be minus sine, our u of x is sine of x, times sine of x prime. And let's get this in a nicer format. Sine of x prime is cosine, so minus cosine of x times sine of x. Be very careful. And this would be the final answer. And let's try one more example. Let's say we want to find the derivative with respect to x of tangent of e to 2x. So the inner function, the function, our u of x, is e to 2x. So that's u of x. So let's think of the formulas. Tangent of u of x prime, it's actually secant squared of u of x times u of x prime. So in our case, it's going to be secant squared of e to 2x, right, times e to 2x prime. Now, this one is an interesting problem, and the reason why I chose it this way, it's because now we want to differentiate e to 2x, and e to 2x is not a simple function like we had before. It's instead of e to the x, I have e to 2x. So now I have another u of x. So it's applying chain rule one more time. So I'm going to continue this. So sometimes we have to apply chain rule more than one time. So we get secant squared of e to 2x times, and how do I differentiate e? How do I differentiate e to u of x? Well, I copy e to u of x times u prime of x. So it's going to be e to 2x times 2x prime. So we get secant squared of e to 2x times e to 2x times 2, because 2x prime is 2. And we can rearrange it just to look a little bit better. 2e to 2x and then secant squared of e to 2x. And this is it. This is our final answer. So I hope this helps.